On the 25th of September, 2025, I entered a comment under Up and Adam's video entitled Aristotle's Will Paradox, to Infinity and Beyond. The comment was along the following lines. This is a nice video. The demos are great. However, jumping from Aristotle's paradox to set countability is a big stretch. It may make people believe that the resolution of the paradox lies on the fact that any two closed intervals are in one-to-one correspondence. It is not. For a precise discussion of Aristotle's paradox, please see. And I added the URL address of my video where the correct resolution of Aristotle's will paradox is presented. To my surprise, within 1 minute my comment was removed, before I even switched to another video. Why was Jade Tan-Holmes afraid of the comment? I doubt that many people would have paid attention to it. I concluded that her insecurity and lack of knowledge are so great that she wants to hide any hint that serious mistakes exist in her videos. Although she has risen to a superstar YouTuber status, a simple but careful investigation indeed reveals various hints that she and her team have a limited knowledge in physics and math despite her bachelor's degree on applied science and despite the physics PhD of her collaborator Simon Morrow. However, I do not want to commit an ad hominem fallacy, and I will defer talking about her and her team. Instead, I will concentrate on the content of their video about Aristotle's will paradox. The video will reveal a YouTuber who is willing to keep eroding the knowledge of thousands of followers instead of admitting her mistake and remove her video, all in the name of the profitability of the video. In the future, I may return to expose additional errors. The viewers can decide about the truth in my statements after reviewing the facts. So, let's start by presenting the paradox and its real resolution. Aristotle's wheel paradox uses a wheel which is rolling without slipping. The contact point C of the wheel with the ground travels a horizontal distance equal to the circumference of the wheel. That is 2 times pi times r, where r is the radius of the wheel. Then, if another point B on the same spoke of the wheel is taken at distance d from the center of the wheel, then we can imagine the smaller wheel of radius d, which rolls in unison with the original wheel. Therefore, point B appears to travel a horizontal distance, which is equal to the circumference of the smaller wheel. For d less than r, the horizontal distance traveled by B is shorter than that of C. For d greater than r, the horizontal distance traveled by B is greater than that of C. However, since B and C are points of the same spoke, this conclusion contradicts reality. Strictly speaking, the paradox is a physics kinematics paradox, and abstract math cannot resolve it. Hence, referral to the lengths of the different paths of points B and C, known as trochoid paths, cannot resolve the paradox. In fact, it makes the paradox worse since the 3 trochoid paths have different lengths, with the path of point C having length 8 times the radius of the wheel, which is not equal to the circumference of the wheel. The resolution of the paradox relies on 2 key elements. 1. What rolling without slipping for the wheel means, and 2. Understanding correctly what the points B and C represent. The wheel performs 2 motions simultaneously, 1 translational motion with velocity v and 1 rotational motion about its center with angular velocity omega. In general, the 2 motions are unrelated. V and omega are not related in any way. Rolling without slipping requires that the contact point C of the wheel does not have a net velocity relative to the ground. This means that the translational velocity of C and its rotational velocity exactly cancel each other. This relation establishes a connection between the 2 motions. However, the cancellation is true only at the contact point with the ground. This also reveals what point C represents. It is that point which is instantaneously at rest. At that moment, the rest points of the wheel purely rotate about C. Hence, point C is not a marked point on the rim of the wheel, which goes around the center. Instead, it's a fictitious point, known as the instantaneous center of rotation, which corresponds to different real points of the wheel as the wheel rolls. Point C moves on a straight line, and because there is no slipping, the length of this straight line exactly matches the circumference of the wheel. Similarly, point B is not a real point. It is an imaginary contact point with an imaginary ground at distance d from the center. It moves on a straight line too. Once the relation of the two wheel motions has been established, the net velocity of point B is easily computed to be non-vanishing. Hence, point B slips while the circle of radius d rolls. The total horizontal length that point B travels is that of the circle plus the slipping, and the sum is exactly the circumference of the wheel. Having reviewed the paradox and its resolution, let's move to the video that Up and Atom has posted on YouTube and has not yet withdrawn. First, listen at the beginning and end of the following clip how Jade Tan-Holmes dismisses Galileo's correct explanation as just an early attempt to understand the paradox.
Let's take a look at another attempt to solve the problem. This puzzle also captivated the mind of the great astronomer Galileo. And to figure out what was happening, he decided to look at a wheel made of hexagons. Just like with the circles, the wheel has a large outer hexagon and a small inner hexagon. When you roll the large hexagon, it travels a distance equal to the sum of the length of its sides, just like a circle rolls out the length of its circumference. Now, let's take a closer look at what the inner hexagon is doing. We can clearly see it lifting off the path. Even though it travels the same distance as the bigger wheel, its sides aren't touching the entire time. I wanted to make this extra clear for you guys, so we're going to mark out the track made by the wheels. There, a nice clean skip. Galileo then imagined what would happen if you repeated the experiment with a shape with even more sides, like an octagon. Here we see that the skips are shorter and more frequent. He then imagined a circle as a polygon with an infinite number of sides. He concluded that the inner circle must be making an infinite number of skips. While Galileo wasn't exactly right, it does get us closer to the modern-day solution.
After this, she moves to present some ideas from Cantor's set theory and cardinality where some subtle error haunt her presentation. She keeps referring to equality of sets, although equal sets and sets of the same cardinality are distinct ideas. Then, based on her fallacious perceived equality of sets, let's hear Jade Tan-Holmes present to her audience the resolution of Aristotle's paradox.
This is called a one-to-one correspondence, and it was thought that if two sets of objects have a one-to-one correspondence, they're equal. Seems legit. Now let's try the same thing with circles. To simplify things, let's roll them out into their circumferences. A circle is just a rolled up line after all. Now we have what would appear to be two differently sized lines. Let's see what happens when we try to make a one-to-one correspondence between them. To make sure that we really are choosing unique points on the line, we have to make a triangle. Draw a line from the tip of the triangle through the shorter and longer line. No matter what angle the line is drawn, it will always intersect each line at a unique point. If you don't believe me, try finding a unique point on either line and drawing back up to the tip of the triangle. A unique point on one line will always correspond to a unique point on the other. So then there does exist a one-to-one correspondence between two lines of different length.
And just to make sure that you understand that she claims that the paths of the 2 points are not equal lengthwise, but they are equal according to Cantor's cardinality concept. Here is the conclusion of her video.
The paradox of Aristotle's wheel took over 2 millennia to solve. While the physical answer turned out to be pretty simple, it led to some very strange ideas about what it means for two things to be equal and the strange nature of infinity.
Moreover, notice that she claims that no physicist was able to understand the paradox and reach resolution. Only a mathematician could do so. I am sure that Galileo, Newton, Huygens, Young, Mach, Lorentz, Einstein, and numerous other physicists are spinning like crazy in their graves. Obviously, there are many flaws in Jade Tan-Holmes' understanding of the paradox, Cantor's set theory, and their relation. First of all, an injective map is not enough to guarantee that two sets are equinumerous. The map must be surjective too. Then, Cantor never called sets equal if they had the same cardinality. Equality is a different relation among sets. He just called them sets of equal cardinalities. This, and only this, is damaging to her argument. However, let's add a few more details. Cantor's result only makes evident a logical fallacy that enters in the presentation of the paradox. More explicitly, when Aristotle presents the argument, he implies that the bijective map between the two circles automatically implies that the circles have equal length. On the other hand, Cantor demonstrates that the bijective map only proves that the two sets have the same cardinality. And although Cantor's result reveals the logical fallacy, it provides no resolution to Aristotle's paradox. Yet, Jade Tan-Holmes does not use Cantor's result to point out where the leap of logic happens. Instead, she claims that this is the latest and correct resolution. That is, points B and C in my labeling do not have to travel the same distance. Their paths are equal because the cardinality for the two circles is the same. This is a crazy claim. Said in another way, when you drive your car, each point of the wheels has traveled a different distance. But that's fine since all circles are equal because their cardinalities are the same. Jade Tan-Holmes has made a huge mathematical mistake. She has failed mathematical logic. Let P and Q be two statements. When Q implies P, the reverse statement P implies Q may or may not be true. There is not enough information to decide. However, if Q implies P, it's also true that not P implies not Q. Contrary to the above, Jade Tan-Holmes claims that P implies Q or equivalently. Not Q implies not P. Let's see how this works in our case. The Q statement is, two curves have the same length. Jade Tan-Holmes uses the word equal, but it really means equal length, since this is the paradox she is attempting to resolve. The P statement is, there is a bijective map between two curves. Cantor says, if two curves have same length, then there is a bijective map between the curves. This is equivalent to, if there is not a bijective map between two curves, then the two curves do not have the same length. It says nothing, though, regarding the relation of the lengths if there is a bijective map between the two curves. The claim, if there is a bijective map between the curves, then the curves have the same length, may or may not be true. However, Jade Tan-Holmes has promoted it to a true status. But if this is true, then it is also true that if the curves do not have the same length, then there is not a bijective map between them. Hence, she has contradicted herself, since it is for curves that do not have the same length, but she wants to claim that they do. If she had used cardinality instead of equality, there would be no mistake. Since Q implies P and P implies Q, the statements are equivalent. Cardinality is a low-level property of sets. Length is a higher-level property, and more structure must be defined on the set before it is introduced. Cardinality cannot define length. On the other hand, length can define cardinality. The true explanation was already given by Galileo. Only one circle rolls without slipping. Any other circle slips. A circle of radius d greater than r slips backwards, and a circle of radius d less than r slips forwards. I will finish with a pessimistic, slightly philosophical statement. Unfortunately, we live in a very curious time. Although the true scientists are the heroes who have helped our society to reach our current technological status, they have been replaced by fake intellectuals. The invention of the TV meant that any good-looking but untalented singers who were willing to take off their clothes were the new superstars, overshining singers with extraordinary voice who did not rely on such cheap tricks to acquire fame. More recently, with the invention of portable devices and the explosion of the social apps, the value of book reading has been discarded. Students do not buy any books anymore. They do not read any textbooks. Instead, they learn scattered material from random YouTubers. Somehow, books and university scholars have been replaced by cute presenters who provide entertaining videos, but often have limited science knowledge and understanding. And what appears as entertaining is actually very dangerous, since it teaches erroneous and fallacious knowledge to young people, which is extremely hard to correct later. Even when the YouTubers are good and well-known scholars, their videos cannot replace a systematic study using a textbook. The videos can only supplement a rigorous study, which requires personal labor and effort. Unfortunately, this is not the reality. It appears to me that our society is moving rapidly towards a second period of dark ages. And this time, it will not be the church that has created it, but the greedy tech industry with their unregulated apps. This video was an effort to help you, the curious mind and the thirsty for knowledge. I hope you liked it. If you did, please subscribe to my channel. Thanks a lot for your support.